Number 11, to raise funds for uniforms and travel expenses, the soccer team is holding a car wash in a part of town with a lot of car and truck traffic. The team spent $90 on supplies like sponges and soap. They plan to charge $10 per car and $20 per truck, and their goal is to raise $460. Write an equation that represents the situation using the variables C for cars and T for trucks. Okay, so they are going to need to charge, let's see, $10 per car, so 10C, plus they're going to charge $20 per truck, so 20T. Do you notice, though, there are also a couple other things in here? They spent $90 on supplies. So think about what that means. They spent $90 in supplies. That means their total profit will not be the total amount here. They have to subtract off the $90 that they already spent, and we want to raise a total of $460. So a little twist to that. They're getting the money for the cars and the trucks. They already spent $90. We're going to have to subtract that off from that total because we already spent it. It's like you're starting at $90 in the hole. You're starting at negative 90. And they're going to save up for a total of $460. Okay, so if they washed 6 trucks, how many cars do they need in order to meet their goal? All right, 6 trucks, so that's going to go in for T. So 10C plus 20 times 6 minus 90 is equal to 460. All right, well, let's do a little simplifying here. That'd be 10C plus 120 minus 90 is equal to 460. Combining these together, that'd be 10C plus 30 is equal to 460. All right, and now we're getting closer, so I'm going to undo now by subtracting 30 from both sides. So I got 10C is equal to 430. So 10 times what is equal to 430? 10 times 43. Dividing both sides by 10, C is equal to 43 cars to get to that total. Use the equation to solve for the number of cars needed if they wash 15 trucks. Okay, so I guess that's the same sort of situation here. So we're going to take a look at 10C plus 20 times 15 minus 90 is equal to 460. So that'd be 10C plus, let's see, 20 times 15 would be 300 minus 90 is equal to 460. These two together would be what, 210? So 10C plus 210 equals 460. Now I will solve, subtracting 210 from both sides. I get 10C is equal to, let's see, 460 minus 210 would be 250. All right, and dividing by 10, 10 times what is 250? 10 times 25. 250 divided by 10 would be 25 cars they would need to wash. All right, number 12. Consider the equation 3a plus 0.1n equals 123. If we solve it for n, which equation would result? Show your work. Okay, so this is one of those literal equations where we're kind of rearranging it and solving for another variable. So let's go see if we can do it. So we have 3a plus 0.1n is equal to 123. And we're solving for n. All right, so we want to, well, let's just kind of circle n here. We're going to get n by itself. All right, so let's start off by moving that 3a over to the other side of the equation. That's a positive 3a, so we will subtract it over to the right side of the equation. So we get 0.1n is equal to 123 minus 3a. Remember, these are not like terms, so it's not like we have like 120 here. We have to keep those 123 and minus 3a separate. And then dividing both sides by 0.1 to undo the multiplication. we get something like n is equal to 123 minus 3a all divided by 0.1. So first off, let's see if that is over here. Gosh, it looks very similar to this one, doesn't it? It looks similar to D, but that's not quite the same as D, because this has ours has a minus 3a, and this over here is a positive 3a. I don't see anything exactly like ours. Remember we talked about in class, though, maybe we just have a little bit more simplified version of this. So if we divide these, maybe we can get this simplified a little bit more. So 123 divided by 0.1. So let's just punch that in just to make sure that we've got the math right here. So 123 divided by 0.1 is 1230. So that turns out to be 1230. And then 3 divided by 0.1. Technically it's negative 3 divided by 0.1, but so that'd be a minus 30a. So that would be another version of the equation. These two equations right here are equivalent. But since I don't see the first version of the equation, let's take a look to see if we have this version of the equation over here. And I think we do, right? That one right there looks to be that version of the equation. So D kind of looked similar, but it's actually C that is solved for n and